Okay, so today we're going to get into something a little different. I have a Rivera M100 tube guitar amplifier, and this has been living in my shed for the last 10 years, and I'm ashamed to say that it's gotten some rust on it. It doesn't look as good as it did when it went in there, but we're going to make sure it works well, and I am giving this to a good friend of mine. So we're going to pop it up on the bench, see what it looks like, see if there's anything we need to address. I'm sure I'm going to have to clean all the pots and switches, take a look at the tubes. I recall looking at one saying it's probably broken, but let's pop it up here and see what we got. Okay, so I got this thing up on the bench here, and the first thing, as I said, that one of these tubes looks like it's lost its vacuum. They get this white milky look to the glass. And when that happens, it usually means that it's time to replace them. So let me pop this out of the socket. Whenever you see this, usually indicates it's a bad tube. So I'm going to pull my tube tester out so we can take a look at these and see what we have. And then I took a quick glance inside the chassis here, and let me just move the camera a bit so you can get a good look at this. If you look carefully, these capacitors have slightly domed, bulging tops. This one's flat. If you notice how this one looks, they should all be perfectly flat like this. When you see them domed up like this, they're getting ready to vent. It means they're very close to end of life. Got another one here doing the same thing. Looks like possibly another one here. Tube amps generate a lot of heat. Capacitors don't like heat. So that could be why these have gotten this way. But we're going to take a look at those, which is going to necessitate pulling this whole board out. Be a good time to clean all our pots and switches while we have it out. And before we do that, let's just go through and check the tubes. I'd like you to see my tube tester. Okay, so this guy here is the B&K model 747B dynamic mutual conductance tube tester. Mutual conductance testers are generally believed to be a better, more accurate tube tester. I just use this for go, no-go testing. I generally buy matched tubes if I need them. I'm not sure if I could match them up with these or not because I've never really looked. But anyway, we need to look up the tube so we can set all these selector buttons, and this is an EL34 tube, which this has a cross reference in here, but it's just going to tell you it's equivalent to the American 6CA7. So let's find that. Okay, well, that makes life easy because the 6CA7 tube has no settings here. So what you do is you select your tube, and your heater gets set to 6 volts. Your sensitivity gets set to 53. Apparently I use it on something a lot like this. And you use socket 14, which is right up here. And we make sure that none of these are selected because you notice these are all blank, and this says 1, which means test button. We have test button 1, test button 2, grid emission, and shorts. So we're going to put this in 14 and see what we get. I really don't expect this tube to work at all. Maybe it will. I'll be surprised. I hit test button 1 and it says nothing. That's our shorts. I don't think it's supposed to move at all, but I don't recall. Grid emission looks good. Test 1. It's not a good tube. Didn't look like a good tube. All right. Next. Let's see. I will probably just replace the one pair. I think the other pair is probably okay. Let's see what we get here. All right, that's starting to go as it warms up. Yeah, this looks like a good tube. No grid emissions. Okay, by the way, that grid emission you see up here says grid emission reject, so that was definitely not good. But this looks like a good tube. On a scale of 0 to 120, it's reading a little over 90, so this one looks good. All right, let's take the next one here. Okay, we'll let that warm up. And then I'll do the rest of them off camera, but you can see what the process is. It's a really nice tester. I got it before the prices went insane. Prices of everything are insane these days. But anyway, bought this years ago. I don't see a lot of tube amps. Almost all the tube equipment I see are guitar amps that belong to my buddies. But yeah, that's a good tube. No shorts, no grid emission. Oh, there is a big grid emission on there, isn't there? I may wind up replacing all these. In any event, I'm going to turn this off and we're going to start concentrating and getting this apart. Okay, so I've got one of these pulled. You can see these are 10 microfarad at 450 volts, which of course I don't have. I have 10 microfarad at 400 volt. This is Murphy's Law at work. No matter what you have, you're not going to have everything you need. So I'm going to have to place an order here. But meantime, this one had kind of a dome top. And let me just show you what I mean when I say that. If you look at the top, it's not perfectly flat. And these are supposed to be absolutely perfectly flat. Take a look at this capacitor. It has a plastic cover, but you can see there's no popping up. Here's another one. This is actually an old cap, but you can see how flat the top is. This one is just slightly domed, and that tells us that this is probably getting ready to go. And when I test it, that's not true. It's already long gone because it's supposed to be 10 microfarads, yet the meter here shows that we have 64 nanofarads and 18,000 ohms of ESR. That cap is useless. So I'm gonna wind up replacing all of those, and there's some other ones on the main power PCB we're gonna change. These go to the tube circuits, which is why they're 450 volt. So I'm gonna have to place an order. Meantime, I did go through here, and since this is South Florida where we are, I managed to find a whole lot of lizard eggs. We have a lot of small non-indigenous species here. They like to lay eggs in electronic equipment. This is where we usually find them. Yeah, welcome to South Florida. So this is a trick or technique that you may or may not be aware of, but I tried to unsolder the first capacitor and I had no luck. So it can help add some fresh solder. So we're going to add some fresh solder here. Make sure it melts in well with the old solder. Okay, now we take our desoldering gun. And I found I had to cut these because I used adhesive not only at the bottom of the capacitor, but also between them. So I find I have to kind of cut between them to free the first one. Okay, I think that might be good. Okay, all right, so we got this one off, and part of the jacket is the one next to it. Again, I don't know how well you can see it, but we just have a little convexity to the top here. That's how you know you have a capacitor that's going south. So when I put this one on the meter, it's better ESR, but less capacitance. It's supposed to be, no, actually, I stand corrected. That is microfarads. So this capacitor, got some glare here. Let me just drop this. This is reading about half the value, 4.5 microfarads and 6 ohms of ESR. Still, I'm going to replace all of them. So let me go back here. I just want to show you one of these I don't add solder to. Well, it actually worked pretty well. Okay, well, if you do get jammed up, adding solder can often help. The first one I had to, the second one I haven't. Let's see if we can get this out. You know what? Yeah, I do need to add solder. It looks like it came out, but it didn't. Okay, looks like I lifted a pad on that one. No worries, we can fix it. Oh boy. Well, lost the jacket to this, so okay, this is our negative. And it doesn't matter, these are all getting replaced anyway. That one checks pretty well though. If you look at that, you can see the meter. It's almost 10 microfarads and it's 0.9 ohms. That one's probably okay. It's not going back in. So anyhow, I'm going to go through, pull some of these others, place a parts order, and we will be back. This was another one I pulled. This is supposed to be 100 microfarad at 35 volts. You can see it's reading 2.6 nanofarads and 419,000 ohms of ESR. That is a bad capacitor. And as you can see, it's only slightly domed. If you see anything that is not perfectly flat on top, you got a bad cap. Because that's the capacitor starting to heat and swell, and the score marks they put in the top are so that they'll burst open instead of simply exploding. I've seen both. But once they start to do that, they're done. Okay, this one's supposed to be 1,000 microfarad. I'm not sure how well you can see this, but it's 49. It's only 44 ohms of ESR though, even though it should be a fraction of an ohm. So yeah, anything that is even slightly domed needs to be replaced. That's a sign that they are shot. Okay, so I've got this thing reassembled, got it fired up, and it's currently in standby, so I'm going to take it out of standby and see if we can get a signal through this thing. Let's see here. Let me just make sure I have everything connected properly. I have our dummy load connected to the speaker output, and I have the input coming from the distortion analyzer, and the oscillator is now on, so let's see what happens here. Boy, this is really ugly. Wow. Not only ugly, there's virtually no output. I don't know how well you can see the distortion analyzer, but it says 0.00 watts. That is seriously low. Let's try the other channel. Okay, about the same, maybe worse. All right, we have We have work to do. Oh yeah, here we go. Same thing. All right, so we're gonna have to take a look and see what's going on. Now, there's something that people who've watched my channel have seen me do, and that's when you're working on something like an integrated amplifier or a receiver that has pre-main jumpers, that is preamp output, main in. So you can break the link and put in a outboard processor, equalizer, what have you. That's a great way to test to see where your problems lie. And in this case, we can do basically the same thing by looking on the back here and putting our signal into the effects loop. Okay, the effects loop return to be, all right, this is our return. Okay. That's not. Okay, it looks like we may still have a problem here because I'm in the effects loop return. Amps on. And our level looks really crappy. Okay, so what we had here was a case of operator error. The effects level has to be enabled by pushing this button, and you see the LED comes on, and when we do that and we look at the scope and I turn the input up, you can see we have nice clean signal. It just starts to clip a little here. That's about 66 to 70 watts. Yeah, we may still have a problem here. Oh, I know. Part of our power loss is due to the fact that I'm set for 4 ohms and I don't have a 4 ohm load on here. No worries, we can take care of that. Anyhow, the output stage is good. So we're gonna have to focus our attention on the input. Okay, now I have the signal back into the input of the amplifier, and I am going to take a look and see if we have signal at our first tube. I'm going to pop a little piece of the schematic up here, and you'll see that our input goes directly into the control grid on V1, or V1A to be specific. The plates are tied together, and it actually looks like they go into both grids. In any event, if we look at pin 1, we should have signal. So let's see what we have here. Okay, pin 1 should be this guy, and we have very good signal out of pin 1. So that's good. We have good signal leaving the first tube in the circuit. Now I'm going to pop up some of the next schematic here, and we are going to want to look at V2 pins 2 or 7. Those are the control grid inputs. So V2 is right down here. And the way the tubes count is you have your alignment gap here, and they count clockwise. So pin 2 should be here. And we have some input. It's a little clipped. I'm not going to worry about that. And pin 7. All right, 1, 2, 3, 4, 5, 6. Pin 7 should be this guy here. That may be channel 2 if I switch them. It is. It's channel 2 and we get quite a bit of output. It looks about the same. So we got signal going into pin 2. Let's see what we have at the plates. Plates are same tube. Okay, 1 and 6. So let's see what we got coming out of this tube. All right, pin 1. Pin 1, we have nothing. 2, 3, 4, 5. Pin 6. We also have nothing. Okay. So now at this point, I'm going to turn the signal off. We are going to start looking for DC voltages to see if we have a problem there. Okay, so we put our meter to DC. Okay, and I'm going to set it somehow so we can both see it. Oh, let me see. There's a bit of glare on here, and I'm trying to get it so we can both see the meter. Okay. Oh, that's terrible. Oh my God. All right, that looks good. Sorry it took so long. Anyway, we're going to start looking for voltages on these tubes. Now we know the first tube is good, and I should have around 210 volts at the plate of V1. First plate is pin 1. They're tied together, so you've seen one, you've seen them both. We have 212 volts here. And if we go to V2, pin 1, that's going to be here. We have, holy crap, we have negative 0.7 volts DC. So we have a problem with this tube not getting power. Okay, I'm going to put the schematic up on the screen so you can see it. But essentially, we should be getting power from the junction of, looks like C107 and R103. R103 is a 2 watt 47K, and that is this guy down here. There's our 212 volts. The other end is 315 volts. So we have our voltage there. And those resistors feed into pin 1 here. And I think we have a break somewhere. So I'm going to put a few pictures up here. We're going to take this apart. And before I do that, I want to show you, since this is a tube amplifier, we're dealing with potentially lethal voltages. And it's important, after we shut it off, that we discharge those capacitors. Because I just shut it off. Okay. Oh, this is dropping pretty quick here. Oh, very nice. Okay. You don't want to just turn this off and jump right in. You could really, really do some damage. Okay. I'm going to shut this off. We're going to pull the board and start taking a look at a few things here. Okay, so I found what our problem is. Our voltage goes from underneath the board here, and it depends on a plated through hole for this capacitor to come up and feed these resistors here. And we have no continuity between, I believe it's this point and this point. This runs underneath the board, and I believe I can get the board out and show that to you. Okay. All right. Okay, I believe I may be mistaken here, because this is the point. This is where we measured over 300 volts on that capacitor, and that feeds into here. Which is the positive side of this capacitor. And if you look very closely down here, this trace comes from underneath this cap and goes to here. And I measured zero continuity. And if we look here, I got my meter in continuity mode, so we are looking here. We have good continuity to here. However, that also has to go over to here, where we have no continuity whatsoever. So what I'm going to do is I'm going to run a wire on the back of the board from this point here over to this point here. Now this is a double-sided board, and that's where the problem comes in. If you look at some of these points on the board, I'm not sure how well you're going to be able to see this, but see these guys here? They don't really seem to go anywhere because they don't, but they do pass through signal or voltage or whatever to the other side of the board where there will be traces. Okay, so I would have preferred they do that here instead of having a component go through the hole, because the through plating on this hole may have been damaged when the capacitor was removed, or it's simply a fact that the solder is not coming up and adhering to the pad underneath here. So I don't like it when they depend on a plated through hole that a component goes through. Now the plated through hole like this has no component is fine. It'll never be disturbed. It should be fine for the life of the product. These, however, are going to have to be changed again at some point. So I just don't care for the practice of using a component plated through hole to pass signal. It may have been okay for something like this where I could actually solder on both sides of the board, but if the plated through part is damaged, it still won't work. So I'm going to turn the camera off. I'm going to solder a wire underneath from here to here, and I believe that's going to take care of our problem. Okay, so now I have put that wire in. I've got this thing plugged in, and if we check our plate voltage at pin 1, right here, now we have 262 volts, and our schematic says we should have quite a bit less. Actually, it says 205, so I'm not sure where the discrepancy lies. Let me look at the other plate. That should be this one here. That's 195. And this one is 260. Well, I might want to look at that, but meantime, we're going to take this out of here. If we look up at the oscilloscope, and oh, I'm in standby too for what that's worth, we have signal. Now, it's distorting a little bit, but you have to remember, this is a guitar amp. Let's see, masters. All right, that's 80, 50 watts. Yeah. Okay. So a guitar amplifier is a very poor amplifier on paper. It has limited frequency response. It has high distortion, but for a guitar player, this is what you want. You don't want low distortion. You don't want wide frequency response. Plug your guitar in a stereo and you'll hear what I mean. But anyhow, I'm going to stick this back in the cabinet and see what we can get out of it. Okay, so this thing's working now. I haven't played guitar in years, so don't expect a lot, but I think I have a microphonic tube because I hear some rattling. But anyway, it's working. So these LEDs seem dim, and I don't remember them being that dim before, so we're going to pull it back out. But anyhow, I think this video is done. Everything's working on the amplifier. I tried some of the gain channels. Let's see, pull gain. Oof, a little noisy, but I'm sure I distorted this little mic badly, but everything is working. So I'm going to sign this video off now. And I thank everyone for watching. And as always, I like giving back to the community that's given me so much. Thanks a lot, folks. Take care.